I guess we could go ahead and get started. It's 9:03. I want to give you plenty of time to do the practice problems I have and then to do your actual work for today. I promise you it's pretty easy. It didn't look hard at all, but of course, if you run into problems and you don't understand something, just ask me. I made a worksheet and that's what I'm going to be writing on. If you want to save it to your drive and just write it on notebook paper, you can. Or if you want to print it and write on it, you can. Or if you just want to write stuff in your notebook, you can. However you want to do it today. And then we're going to use calculators. So if you want to open up the calculator on your laptop, phone, whatever you got, we're going to be doing some calculations. I think I changed the numbers to make it easier. Some of the numbers I changed. So you won't be writing too many decimals. I tried, guys. I tried. All right. So we're doing mechanical waves again. These are waves that cannot go through space. They cannot go through space. They have to have a solid, a liquid, or a gas. And mechanical waves usually deal with sound waves like us talking, us listening to music, water waves that you see in the ocean, guitar strings, harp strings, any string instrument, basically any vibrations, any disturbances or waves. So we talked a little bit about periods already. And period is the time it takes to complete one wave cycle. And remember, a wave cycle is anywhere between two identical points. So here would be one wave cycle. And we would just count the time it takes to complete that one wave cycle. So the formula for period is going to be, well, first, let me tell you the symbol and the unit, sorry. Period is going to be having the symbol capital T. So anytime you see a capital T, that's period. And the unit is going to be in seconds. So we're measuring it in seconds, or just S. Little s means seconds too. Oh, I'm using the wrong pen. All right, now for the formula.
Oh, you're using all the wrong pen. We're all screwed.
Well, because look, it looks like spotchy. You know what I mean? Like, I don't know.
That's fine to me, but then again, I mostly use a pencil.
Yeah, pencils are great. But sometimes with the way the light reflects pencils on here, it's hard to see it sometimes.
You know, there's actually erasable pens.
I don't need erasable pens. I just need a pen.
Yeah. So
the formula is period equals time divided by number of cycles. So just the time over the number of cycles. That's all it is for period. So let's go ahead and do number one. A clock clicks 88 times in 22 seconds. Calculate the period of the clock. So period again is a capital T. And to find it, we're going to do time over number of cycles. So our time is 22 seconds. Our number of cycles is 88 because it clicks 88 times. 22 divided by 88. 1/4, yes. Oh, which would be 25. 0.25 seconds because our unit is in seconds. Easy peasy, right, guys? Pretty good? Do we feel good?
Yeah.
Oh, yeah. No, you're fine. Sometimes I do go fast, so if I need to pause, just let me know.
since the time, if it was in minutes, how would you?
If it was in minutes, you would have to multiply it by 60. Good question, but I don't think I did that to y'all today.
And it always has to be in seconds.
It does always have to be in seconds. Yes. Good questions. Actually, I don't think I gave you any time. Yes, I did. No, I didn't. I think I gave you one thing that has a time, but other than that, pretty good. All right, are we ready?
Yeah.
Okay. So now we're on to frequency, and the frequency is the number of waves passing by a specific point per second. So if all three of these waves were passing by in 1 second, then our frequency would be 3/1. The symbol for frequency is going to be an italicized F. So I just draw it like that. It looks like a S with a line through it. And we measure frequency in hertz. Or just Hz. They mean the same thing. Hertz and Hg. Hz, sorry, Z.
Gigahertz.
Diahertz?
I said giga.
Gigahertz? What's a diga?
I said giga.
Giga.
G.
Oh,
Gigahertz.
G, yes. How much is a gigabyte? A billion? No.
I think it's like
I think it's like 1,000 megabytes.
Oh, okay. Oh, that's megabytes. So 1,000 times a million? Because a mega is a million, right? This is too complicated. Let's carry on. Okay, anyways, sorry. The formula.
Science is complicated.
The formula for frequency is going to be frequency equals number of cycles over time. So if you notice, it's kind of like period, it's just swapped.
So if we get a whole number, or if we get a whole number for there, for the same question, for period, if we had the same question for frequency, we'd get a fraction.
Yes. But most of the time, periods are going to be smaller than frequencies because usually time's smaller than the actual frequency. All right, so number 2, a young girl sits on a swing that completes 20 cycles in 25 seconds. What is her frequency? So we're looking for frequency F, which is number of cycles divided by time. So number of cycles is 20. Time is 25 seconds. 20 over 25. That would be 0.80 hertz. It's already in seconds. What do you mean? If it was minutes, you'd have to change it. All right, so like I said, the formulas for each other are kind of flipped. That means that period and frequency are going to be inversely. And for some reason, I forgot how to spell inversely. Related. Yes, they're inversely related, meaning if you increase one, the other's going to decrease. If one goes up, the other goes down. So with that being said, we can write whole new formulas for frequency and period. And these are the actual two that you're going to use the most. You can use the other ones. Just remember to flip them if you're trying to find the other thing. But these are going to be a lot more easier to use. If you're given frequency, you need to find period, or if you're giving period, you need to find time. Whatever I said. So the formula for frequency is going to be 1 over period. And the formula for period is actually going to be 1 over frequency. And that's again because they're the reciprocal of the other. So we're allowed to do this because we're just flipping them upside down. So for number 3, a period of flashes on a stroboscope is 0.0125 seconds. So that's not the time, that's the period because it says the word period. So just keep that in mind when you're reading these. What is the frequency of the light flashes? So we're looking for frequency. It's 1 over our period. Oh, what happened? Yeah? Sorry. My thing froze. There we go. Frequency is 1 over period, so you're just going to do 1 over 0.0125. Your frequency is going to be 80 hertz. How are we liking it so far? Good? Told you today would be pretty easy. All right, let's see if you can get the next one on your own. I'll zoom in a little bit so y'all can read it more. A spring vibrates with a frequency of 400 hertz. What is the period of the spring?
Got it.
If you did it correctly, you should have got 0.0025 seconds. Did anyone not get it? It was just 1 over the number.
Regular, but like it was
Still the same process.
002. It's just I missed the 5 because of
Oh, trust me, that happens to me like all the time. Especially in my math class, it's just like you mess up one thing and then suddenly the whole equation's wrong.
That's why I don't like derivatives.
It's a pain in the butt.
So how do we feel about periods and frequencies?
easy peasy.
Easy peasy?
Meh.
That's what I like to hear.
Hey, I have a duty that I have to carry out every morning.
I wish I could do that.
I mean, you can.
Oh, yeah. I will be in school every day. Or at least in the mornings. I could definitely do it in the afternoon.
Colonel doesn't want anyone doing that. Yeah, such for 7th period. Well, it's really for the schedule people in the afternoon.
Okay. I'll see what I can do.
It's It's okay, we got 3 freshmen, I'm just playing.
No,
Okay.
I want badge. Or ribbon. What's the ribbon?
Something of value.
You get
It's our
it.
TCS. I'm just-
All right, are we ready? Yeah,
What? Oh, yes.
okay.
See.
Let me zoom back out. So wavelength doesn't have a formula, but it's part of a formula. So I just wanted to remind you what wavelength is. And it's the distance between 2 identical parts of a wave. So as long as you have identical parts, you're good. For example, if you're going crest to crest, this would be your wave. Has to be identical. I don't think we have worksheets this year that are going to be asking you to measure waves, so that's pretty good. But if this was a regular physics class, I would print out a paper of waves, give you a ruler, you would have to measure wavelengths.
And wish you luck. And wish you don't go insane.
No, wavelengths are fine. You can measure with a ruler, I hope.
Isn't this what you're referring to?
Did you go over wavelengths in chemistry?
We did formulas or something for waves.
That's cool.
Oh,
I did not teach that when I was a chemistry teacher. All right, so now we're getting to the wave formula. This is wave velocity. It's the speed at which a disturbance or wave moves. So it's just like regular velocity, distance over time, except now we're dealing with wavelengths and now we're dealing with periods. So the formula is going to be V for velocity, but it's going to have a subscript of W because it's a wave. It's not regular velocity, it's a velocity of a wave this time. And that's going to equal your wavelength, which is that upside down Y, times your frequency, which is that italicized F. These are weird symbols, I know.
Yes, big brain symbol.
Don't you just love physics?
Yes, actually, I'm doing good in that.
Good, I'm glad. So there actually is a triangle this time if you like using triangles. Again, you don't have to.
But I recommend you do. It makes things a whole lot easier.
It does. And also in the formula chart, the teacher was really nice who made it and she rearranged them for you. So we're trying to make it easy. We're almost done. We don't want to make it too hard.
At this point in the year, things just start slowing down a bit. Things just start getting easier from here.
Yes.
And then,
So,
like, at the last week, we all the classes just basically just hang around.
yeah.
All you gotta do is, I think for this, all you gotta do is just pop in and then you're good to go.
All right. So if you're using the triangle, velocity goes on the top, wavelength and frequency go at the bottom. Wave velocity. Let me write that out. Sorry. So VW equals wave velocity. And just like all velocities, it's going to be measured in meters per second. Unless you're dealing with big waves, then it would be kilometers per hour, which we're not doing that. The upside down Y, that's wavelength. And that's going to be measured in meters. R just the M. Same thing. And then hopefully you remember what F means because we just did it. That's frequency. And that's going to be measured in hertz. Hz. So if you're doing these problems on your own, you don't have to write VW. If you just write V and you know that's the velocity of a wave, then I'm perfectly fine with you writing just V. You don't have to show your work on today's assignment though, so no worries about that. You ready for your practice problem? I'm gonna let y'all do number 5 on your own because I think number 5 is pretty easy. A vibrating source with a frequency of 20 hertz produces water waves that have a wavelength of 0.3 meters. Calculate the velocity of the waves.
Got it.
Good job. If you're doing this correctly, all you needed to do was multiply your wavelength times your frequency. Wavelength was 0.3 meters. Frequency was 20 hertz. That should give you 6, and your units are going to be meters per second. Any questions? All right, let's do number 6. A wave that travels at 10 meters per second has a wavelength of 0.20 meters. What's the frequency of the wave? So now we're looking for frequency, and if you're using your triangle, cover up that F. So it's just your velocity divided by your wavelength. So it's V over wavelength. This time I'm not going to do algebra. This time I'm just going to write the formula as is. Frequency equals VW over wavelength. I know my velocity is 10 meters per second. I know my wavelength is 0.2 meters. And I'm looking for frequency. Plugging all that in, I have 10 over 0.2, which gives me 50, and my units for frequency is hertz. Ready for the last one? All right. A water wave travels along a deck at 4 meters per second.
Doc.
Oh, sorry, dock. At 4 meters per second.
A doc.
An observer notices the frequency of crests as they pass the first dock is 2 hertz. What is the wavelength of the water? So now we're looking for wavelength. And if you're using your triangle, to find wavelength, you just cover it up, and it's your velocity over your frequency. So it's velocity divided by frequency. Again, I'm not going to be using algebra. I'm just going to write it as is. Wavelength equals velocity over frequency.
Good, no one heard me.
I heard you. I nodded.
Everyone, what, you didn't hear me.
4 divided by 2 is 2. And your unit for wavelength is meters. Hopefully you feel comfortable with this. Hopefully it doesn't seem too hard. But again, if you have any questions on today's assignment, let me know. You have the remainder of the class to work on it. I haven't updated grades yet, but I should be done updating them by today around 4. So if you want to take a look after 4, your grades should be updated. All right, if you have any questions, stay on. If not, you are free to go.